Unit 11, Prerequisite Skills. Once again, these are skills that we learn throughout the school year, and they are going to be very important that you understand them in order to be successful in learning the very last unit of the school year, Unit 11. Section 1 deals with determining if a given point is a solution, and we've done this multiple times throughout the year. Basically what we're doing is we're taking the point, x, y, we're going to substitute it in to the correct location in the problem, and then we're going to simplify. Alright, so that would be 4 equals 4, which of course is true. So we would say that yes, 1, negative 3 is a solution. Okay, another quick example, same thing, going to plug my pieces in. Be really careful with my substitution. That's going to be 4 minus 3, which is 1. Also checks out. So we're going to say yes. And now when we learn this, we actually learn two ways of saying this. Alright, we can say yes, it's a solution. We can also say yes, the point 1, negative 3 is on the line. Okay? And basically the idea was a point is a solution if when graphed, it's on the line. So it's part of the graph. Alright, in other words. Okay, speaking of graphing, section 2 deals with graphing linear equations. And in unit 8a, we learned two ways to graph linear equations. Alright, the first one when y is by itself. The second one was when x and y were on the same side. Okay, I only meant to do that. Alright, there we go. So when y is by itself, this is known as slope-intercept form. And we learned about slope-intercept form being y equals mx plus b. So in this problem, my m would be negative 1 over 1. Should be a negative there. And my y-intercept is 0, 3. And the way we graph this is we went 1, 2, 3 to the y-intercept, and then down 1 over 1, down 1 over 1, down 1 over 1. One of the things we said is it only takes 2 points to make a line, but the more points you put, the more accurate your line is going to be, and that's going to be a huge deal in this chapter. All right. Another thing we talked about quite a lot in this in 8a is when we draw a line, it doesn't stop at the point; it extends all the way through the graph. Also, another huge point in Unit 11. Make sure you're drawing your lines all the way through. Okay, in B, when x and y are on the same side, we called this standard form. And what we did then was we found the x and y intercepts. The way we did that was in order to find the x-intercept, we would say, okay, the y is gone because it's 0. So we're going to get rid of it and say 2x equals 3. Okay, and then we solved and we said, oh yeah, that 0 matters because this is an ordered pair, so that's the point right there in between 1 and 2 because 3 over 2 is 1.5. Alright, so 3 over 2 comma 0 is the point. And then we went back and we had to find the other one. Alright, and the way we did that was basically the same thing. We're going to say, okay, now the x is 0, don't look at it, we end up with y equals 3. And that gives me a point where the x value is 0 and the y value is 3. And once again, we have our points. Now, with this method, you only get 2 points, so make sure they're right. And then again, we're going to make our graph as long as we can, extending all the way through the given graph. Okay? Creating long, continuous straight lines. All right, linear equations, something we've been talking about an awful lot. Some more U-tries for you to do. All right, moving on. Section 3. All right. Solving multi-step equations, something we did all the way back in August in Unit 2. Basically, it required 2 steps. Step number 1, we said would be simplifying. And the way we simplify is first we distribute, and if possible, we collect our like terms. The second thing we need to do was solve. Okay? So in step 1, I have parentheses, which means I have to distribute. Remember, we don't always have to do these. If they're not in the problem, we can't do it. But in this case, we have it. So positive 2 times positive 3 is going to be positive 6x plus 4. Again, everything else stays the same. So my x drops, my equals 11 drops. Okay, now I need to collect my like terms. I have an x and a 6x. That'll give me 7x. Alright, the 4 will drop, and so will the 11. Whoops. Wrong color. There we go. And now the last thing I have to do is solve, so I'm going to subtract the 4 from each side. Get 7x equal to 7, divide, and x is equal to 1. Okay? Looking at b now, again, we see the parentheses, so I'm going to distribute first. That's 8y minus 24 plus 6y, and that's going to be equal to 4. Then I'm going to collect my like terms. Right there and right there. Okay, that's going to be 14y. My negative minus 24 is going to drop down, and my 4 remains unchanged at this point. Now I've simplified, now I could solve. So I'm going to go ahead and add 24 to both sides, and end up with y equaling 2. Okay? So again, this is solving multi-step equations. Last one, part C, is going to bring up something that happens from time to time that we have to know how to handle. Alright, and it's going to look like this. First of all, same thing as before. We're going to take care of our distributing. Alright, everything else stays the same. Now we're going to collect like terms. Negative 6 and positive 6 is they're both going to be canceled out and become 0. And that leaves me with this statement. Negative 12 equals negative 12. Okay, there's no more variable to solve for. That means we're done with the problem, but we have to say something. Alright, if this is a true statement, we learned that we're going to write infinitely many solutions. Alright, or we said for abbreviation's sake, we would say all real numbers. Alright, we'll just say all reals. Alright, basically it's the same idea, but infinitely many solutions is the way we want to word it. Now that's if it's true, which in this case it is. If it happened to be false, which it's not in this problem, but if it is, that would be our no solution answer. Okay, so again, if false, it's no solution. Alright, 3 more U-tries for you to do, and one last example here. Alright, in 8b, we learned how to write linear equations from word problems. Alright, and what we learned was, first of all, obviously we need to read the problem, and we're looking for 2 specific things. So we have a mechanic that charges $35 per hour plus the cost of parts. The per hour is a big deal because that represents a variable cost. Okay? Meaning, in other words, we don't know how many hours, alright, we're looking at. Alright? Plus the cost of parts could also be a variable. However, in the next statement it says the total part cost is $100, so we know what the cost of the parts are. Alright, we're asked to write a function to determine the total cost for X hours of labor. Okay, so again, we're being told what the variable belongs with. Alright, so we would write our function, I'm going to use P for price. Alright, P of X is equal to $35 per hour plus the cost of parts, which is $100. Also keep in mind that we've been saying, you know, when it comes to graphing, the P of X is the same as saying Y equals. Alright, so understand that that notation can very easily be changed if you need to graph. Alright, that's it for the prerequisite skills. See you in class.